Okay, so you're welcome back to episode 15. So we're down off the bench for this one. Now, this one, I wouldn't normally do a part like this just because they're not really that exciting, but I got a request from a Formula student team that were based in America. Now, they did a car some years ago, but they've since got together just as a bunch of guys, and they're designing a Formula 3 type car sort of layout. I won't say much about it, but it resembles a Formula 3 car. It's a 2 litre car, open wheel, and they got in contact with me, as I said yesterday. I think it was last night or yesterday. Um, just wondering, had I a Cockpit Surround in stock, or was I willing to do a video on it, or had I any information? Now, to save sending them the information on it, and only them knowing about it, they're not too worried who knows about it. So what I shall do is have a look at this one here, make a video out of it. As I said, not going to be too exciting because I just find these sort of parts, like you're venturing into to aero parts, which I will probably never cover because they're just objects. They're cool and all that in their function, but in terms of technical aspects of them, internally or externally, they're not really exciting. But getting back to this Cockpit Surround here, this is off the FW25, so it was the BMW Williams car. It's a while old, but its design methods and its principle hasn't changed over the years. So I'll talk you through it. I'm down on the floor here at the moment because the bench isn't big enough, and I can see a whole lot of stuff off to the sides when I put it on the bench. So we're on the floor. Much brown paper was bought today, so thanks to everyone that bought coffees. It went towards more brown paper, as I said. So let's have a look. So the Cockpit Surround is taken off the car when the driver needs to get out generally, or get in and out, because it's just so tight. Like if you look around the helmet there, there's only like an inch and a half, 35 mil or whatever either side of the helmet. So it is quite tight to get your shoulders in. So once this is removed out of the way, the driver can get in easier, and then this is put on. Now, a lot of people get shocked if they've never seen a Formula 1 car, is just how low the driver sits in the car and what his visibility is like. Now, as you can see there, if I push back the helmet, and this is just the helmet I use on the bike, it's not a Formula 1 helmet or anything like that, obviously. But if I just push back the helmet there, it just contacts with the badge, the BMW badge. So that's pretty much the height of where the driver's head would be. Now, obviously, this is to protect the driver's head in a crash, to stop any neck forces or breaking his neck there underneath, just above his shoulders and between his skull. Obviously, he'd be wearing the hands device as well, but this just provides extra protection. Now, normally with all cars, the worst way you can crash a car, as you'd probably know, the guys that are watching these videos that work in the recovery trade, every time you come up to an accident and you see the car has a side impact, it's never good. It's never pretty. Cars generally aren't designed for side impacts to T-bone into a tree or whatever, or a lamppost. So Formula 1 cars are generally kind of the same. They've got a huge crash structure at the front, same at the back, but the side just needs a small bit more protection for side-to-side head toss is what it's called. So I'll give you a walk around it, and we can bring it up on the bench then and do a few sections. Now, this part I've had for a while, so I'm willing to sacrifice it to bring information into the world. And I mean, I don't know what they're worth now. I have no idea, and I don't even want to look. But I'm willing to section this part to make a video. I'm thinking of the guys stateside which are designing their car. They're going to learn, so it'll all be good. Now, as I said, this locates into the car. Now, there's a few different things on this part. It's carbon fiber and foam internally. It locks down in the front, then locks in the back. You can see if I just steered the camera around here. Now, this, when I'm down on the floor, the camera work isn't going to be spectacular because it's just a bit more awkward than being on the bench. But the rear here, as I said, the rear would lock in. This is a slightly thicker carbon fiber, which we'll cover shortly when we get up on the bench. It locates into two dowel pin holes here and here, which will be on the monocoque, and there's also then Velcro as well just to give it an extra cozy fit, just to stop it fretting like that, or rattling, or whatever you want to say. On the front, if I just spin around to the clip on the front, they're quite simple. These would locate into, again, dowel pins that are sticking out from the monocoque, and then you would put just a clip down there, a clip down here in the top, which would lock in that pin. So pretty simple. In terms of getting out, then you pull your two pins here and this one here. This would lift up, the whole thing would lift up, hinge up like this, and you could lift it away, and then the driver could get out. If I flip it over, actually, just one more thing while I'm here. This here is a helicopter tape, so that's kind of what it's called in the trade. I'm not totally sure what the real name is. It's probably made by 3M, but it's the same tape that's used on the leading edges of helicopter blades, just to stop erosion if you're flying in a dusty area or a desert area, or flying over sand. This will stop the particles eroding away the front of the aileron shape on the helicopter blade. But it's used here as well for the same principle. Just if the driver's head knocks against it, you know, when he's fixing himself in the car, that it won't wear away the paint and fret the carbon fiber, which is a high energy area here. It's a joint, as you can see. It's about an 80-degree angle, so it's a high energy area here, which would get fretted away quite easily if they had no helicopter tape here. So if I flip it over, I don't think there's anything else on the top. The paint is spectacularly thin. It's like, if any of you've seen or driven the Ferrari F40s, the early ones, you can see the weave through the paint. So again, paint on all Formula 1 cars is very thin, because more paint is more weight. And on the F40s, as I said, if you were ever near one, you can actually see through some of the early ones. You can see the weave quite clearly like this. Hopefully that focuses. So you can see the weave there, just there where the light was reflecting. It was a big problem with the early F40s, because the engineers applied the paint as thin as possible, because they wanted it as light as possible. And when the F40s then came out of Italy and went into dealers in mainly, I think, the UK, a few in America as well, a lot of the customers were complaining that they could see they were after spending all this money, and they could see the carbon fiber weave through the paint. So would you believe it, a lot of the F40s were painted by the main dealers after coming out of the factory. They were all flattened, primed again, and painted, just because they got a good few complaints. Now obviously, if you're a race guy, you know, I prefer to see the weave. It means a lighter car. But there was some people buying the cars that are as showpieces or investments, and they weren't at all happy about this. So that's a tangent about the F40. But the later cars, then, they just went to more trouble flattening the weave first before they applied the paint, and this went away. So if you're in a foreign country and you're not up to speed with number plate years and all that sort of thing, you'll know, if you can see the weave through the paint on an F40, that it's an early car. So if we flip this over, I'll take out the helmet, because we don't need that anymore. So you can see as well here the foam inside it, which there's a lot of talk about on the internet, and the main concern the guys have, the Formula student guys, which is what this video is kind of, the question has been answered for on this video. So you can see the breather holes there for the foam. Now, as I said, this part is made up of two different types of carbon fiber layout. You've got one strong one here, which is like standard fiber. Let's just say it's 3/4 millimeter thick, 0.75 mil thick, or whatever that is in mils, 20 thousandths, I have no idea. Sorry to the Imperial guys. On the back again, it's the same thing, thick, but because this needs to comply here at the head and shoulder area, if this needs to comply, as in squeeze, if this was rigid fiber, then the foam internally would be pointless, because this fiber would cut into the driver's neck here. So this is actually a really thin fiber. It's like I think 0.3 millimeters thick, and it's used with a different type resin in the pre-preg, which is almost like a rubber epoxy. It's a general purpose kind of epoxy pre-preg, but before the resin is introduced into the carbon and it's frozen, there's a plasticizer added to it, so it just means that it's very flexible, and also of course it's very thin. Like it's really thin, so this can all bend. Now you can see a few crack marks there, just as the forces from the driver's head or whatever he was leaning against. You know, it's really thin. You can see it there in the paint. It's not structural at all, this carbon fiber, at all. It's just something to carry the paint and contain the foam. Now obviously it has a huge burst pressure containment strength, but it's not designed for any axial forces in the Y direction, if you want to call it that way. Same with all parts of the headrest. This is all again soft. You can see it's really soft there, like it's really thin. So that's just where the helmet was chipping off it as you'd be driving around the track. Now this, I know this for a fact, was out of a test car. I bought this some years ago off a supplier I know well. It was out of the FW25 test car, and you can see T car mark in the back of it there. So that's that side, I think. Now if we flip it over, so this will be all made in one mold here, the top part, simple enough mold, and it's turned over. Then the part is taken out, the thin carbon fiber part is taken over, it's turned over, the foam is inserted, and the underside then is bonded in. You can see the bond line hopefully there. So that would be a post bond after it comes out of the autoclave. So again, the bottom, you can see it's really thin. If we turn around to the rear, so this is just where this rear gable here comes up. Again, this is a strong gable. Remember, it's thick carbon fiber with the Velcro. So this all comes up here. So this is strong here at the back because it's against the, let's call it the engine bulkhead over the fuel tank, and it curves in. And again, this is the bond line along here where the really thin fiber is put into it. So this is all thin fiber on the bottom so it can crush. And I think that is that in terms of overview. So what I'll do now is pause the video, section it, take out some of the foam, show you the foam, show you how they did it, and I shall talk to you in one sec. Okay, so I've sectioned it up, and as you can see there, it's all cut up into bits now, and I found a few very cool things inside it, which I wasn't aware of, but I'll show you them as we go. So the first cut, like I get a lot of questions sometimes on how you approach a part when you're cutting it up. So I generally look at the part first and think about if I was to make it, or how you would do it, how it's bonded together. Now, if you cut a part up the wrong way, sometimes you can't necessarily see bond lines which you've cut through or how it was made. So in this case, obviously the foam has to be put inside the part somehow. So I knew this would display all the join lines. You know, there's 4 on the 4 corners. So that was my first cut of choice there, straight down there, just with a small grinder. It's the best thing for cutting carbon fiber, as horrific as it sounds, but it does work. Obviously mask up if you're cutting carbon fiber, and keep all electronic devices well away, because the dust is conductive, and if that gets into your electronic things that you cherish, it's going to fry them. But so the first cut was here, which then displayed the cross section. So we can now see there's 3 sides here. There's the bottom here, there's this side here, and there's the top. So that's all thin. Okay. And the outside section here, which goes against the car, is thick. And you can now see the lap joint there where they joined it, right there in that corner, and there on the bottom corner. So we now know that the inner part of the head surround was made in one piece, the three sides, and they're the thinnest areas, so that would make the most sense. And it would also then make the most sense for inserting the foam, which I'll show you in a moment. So going back to what the thin layer of carbon fiber was made from that can collapse, I'm going to go back on what I originally said, that it was an epoxy that was flexible. It's actually not. It's a carbon fiber Kevlar weave. Now hopefully you can see the Kevlar there. You can see the yellow and the way it's frayed. So that's why it's so flexible. The Kevlar, as you know, is used in bulletproof vests, timing belts, all sorts of belts like that, clothing and various things. So it's not as brittle as carbon fiber. And this weave here is mainly Kevlar. So that's where it gets its flexibility from. Now you can crack the epoxy if you try. You can hear it cracking there, but the flexibility comes from the Kevlar. So it's just normal pre-preg, very thin, but it's, I would say, about 75% Kevlar in the weave. So that is that. Now again, this outside surface here is a lot thicker, and it's complete carbon fiber. If you go back to the other carbon fiber videos, you can see it's skipping over there for 2 and going under for 1. So we should know all about that from the pushrod video if you've watched it. But that's just that. Now I will stop the video again. Now that I knew that, how it was put together, I can now continue to cut the rest of the part open on the joint line as it was assembled, and I'll give you a look at that. So chat in one sec. Okay, so with the parts separated, you can now see a fair bit going on. So let's just ignore what's over there for the moment, and I'll talk you through the Kevlar carbon first skinning, if you want, or the first part that was made or put on the bench in order to assemble the entire part. So this is all the thin part here. So you can see that it's very flexible, really flexible here and here, as mentioned. And the bond line then would be here and here, 90-degree bond line of the thicker carbon fiber to bond them all together. Now this part obviously would be made like that. This leg on here too. The foam then inserted, and the outer part, which is there, bonded in. Now let's just run through this in a bit more detail. So looking at the back of it, which I was wrong actually at the start of the video, it's the FW24 and not the 25, but I laughed when I cut it open and saw this. So it's just to show you over here. So it's the test car, and it's FW24 part number 1. So if you're cutting up parts, make sure they're the rarest parts possible. So that's that. See the bond line there, where the epoxy would overlap and the foam would insert into. So hopefully you've got all that. Nice part, again made on a tool this way. The A surface would be on the inside, the smooth surface, and the peel ply layer and the vacuum bag and all that stuff would be on this layer here on the inside, the back layer, where it's rougher. You can see the folds from the peel ply there, and probably down there at the side on the junctions, you can see them there again. Now it is reinforced here a tiny bit more than the rest of it, just because there's a change of ply directions, so that is a bit firmer there, but the rest of it is flexible. Now onto the foam. So I'm not sure how many viewers are up to speed with foam, but this is what's called an open cell foam. Now it's It's fairly common. It's common in car seats, in orthopedic sort of things, in generally a lot of stuff really. There's two types of foam in principle. One is called an open cell foam. The other one is called a closed cell foam. Now, what is the difference? The difference is this. If I just get out the trusty marker again and brush away the carbon fiber dust, which is in my hands, well, so a closed cell foam is made with a chemical reaction. It's generally made in big blocks. It's two resins mixed together. They react and they expand. Now, on a closed cell foam, it's like this. There's a load of bubbles inside foam, as you know. Let's just pretend they look like that. So that will be a closed cell foam. So the two chemicals react together. They create an exothermic reaction. The gas inside here, or the air inside here, expands because when something gets warm, the air inside it expands. And the resin itself then skins over, and so that's a closed cell foam. So with an open cell foam, the difference is the cells Siamese together, which is going to be hard enough to draw, but let's try anyway. Let me look at the page and not the camera. So they'll be like this. This isn't great. So you get the idea. With an open cell foam, each cell can communicate to each other like that, like that, like that. The air can travel between them, and so on. So in principle, like this foam here would be ideal for, let's say, insulating your house, so that the air cannot travel through it. Again, it would be ideal for insulating or for use in a boat, in that it would provide buoyancy. That if you had a break in the hull here, the water could not travel past this cell, into this cell, into this cell, into this cell. So this is used for insulation and buoyancy. Now, because this is controllable, in that you can control the cure rate. If these are slower to cure, they can provide voids between the cells. They don't skin over as soon, and you have a communal area between all the cells. This can be controlled in that the air can travel through it and provide, in this case of the Cockpit Surround, it can provide energy absorption. Now the smaller these are, the more impact it can take, because it takes longer for the air to compress to travel through each cell, so the foam is slower to react, if you like. So the bigger these are, the softer the foam is. Now, I've worked with this foam a lot in the past, as it happens. It's called Contour foam. It's used a lot everywhere, as I said, from orthopedic chairs all the way up to motorsport seats, to Rolls-Royce use it in prototypes, in bolsters, in dash panels. It's used a lot. Obviously it's used in Formula 1 as well. The blue foam has a temperature rating which is over, I think exactly off the spec sheet, it's 31.8 degrees, just because at various temperatures it reacts differently, so its compression ratio is different. So over 30 degrees, or 31, I think it's 31.8, this is the foam to use. If it's below that, you need a more what would I call it, a more solid foam, just because the temperature is lower, and it will behave the same as this. So there is a variation in the foam types because of the temperature differential, or delta, but that's a basic rundown on the foam. Now, just getting on from that, if you'll notice here on this part, before we get on to the parts overall, you're probably wondering why there's a foam tape here, or a tape on the foam. It's a, I don't think it is a foam tape, no, it's just normal tape, but let's call it sellotape. So the reason they put tape here and tape here as well, all the way around the bottom, is going back to this here, because it's open cell, because this is behind a bond line after they put it in, and they bond in this part here on the outside, because that's bonded into the thinner layers, and you're using epoxy here. If the epoxy was to bleed into the foam, which as you see from this it can do, your epoxy could bleed all the way in here if you use too much. It's going to change the properties of the foam all the way into here, because with capillary action the open cell foam will soak it in. So all of this foam would then become solid if you didn't isolate it from the bonding epoxy with tape. So that's why the tape is there. It's there in all the edges that are exposed to the bond line, and that is why that is there. But getting on to the foam again, I use a lot of this foam, as said. I'll show you a block of it here. This is a block from an old project. It's the same foam. It comes in thicknesses of 70mm thick. It's quite expensive. I think from memory a sheet roughly 8 foot long and 3 foot wide and 2 inches thick is about €1,000. So it's not to be sneezed at. Now this foam is not poured. It's poured in the factory when you buy it. It's poured like this. You buy it like this, and you can see the cell structure there. But you can then CNC machine it. Now I know some people are wondering how you CNC machine foam, but it can be done very easily. It needs cutters that are really sharp. Now, because of their nature, carbide cutters can't be sharpened that sharp. If you're using machine tools, you'll know this, mainly because they're so brittle and you just can't get a sharp edge. Like if you look at an edge on a, just say a simple knife, if that was a carbide knife, you can only go so far here before these will just break off the edge of the knife. So with a high-speed steel cutter, it's more ductile and you can get a far sharper edge on the tool. So if you're machining foam, use high-speed steel cutters. Use a strategy which is called conventional machining, which I don't really want to get into now. I probably will later. There's climb milling and conventional milling. Climb is used in CNC machining. Conventional is used with manual machines, but you have to cut foam with the conventional machining strategy if you are going to venture into that. But getting back to the foam structure here we have in front of us. So this was made, as I said, it's 70mm thick. You buy it like this, 70mm thick, and you can probably see there this was made from layups 70mm thick, 3 pieces bonded together and then machined. Now obviously if you don't have a foam the right size, you can join it together, which these have done here. There's a glue line there, there. Now the one thing I will say with this part is the glue they used is fairly strong, or should I say brittle and hard, which I wouldn't be that much of a fan of. I would prefer to see something softer. This glue line here is acting like nearly a bulkhead, so it just changes the property of the overall foam. So if you are bonding foam together in a structure like this, use something that resembles the density of the foam, and you should be okay, because these are quite hard. But just getting back to the foam properties, if I press on it here, you can see it is quite slow to react. So that is just directly related to the airflow flowing in and out of each cell, which can be tailored. But so yeah, that's that. Now what I'm going to do is pause the video, turn this part around and talk about just how it was made, why I'd probably change the design just to make it simpler to make, and that should be us. Chat in a sec. Okay, so just breaking it down a small bit. you're probably wondering why there's a very thin bit here. It's about 20 mm thick. You can see it on the back there as well, just at the bottom. This was designed in because there's an undercut here on the general outer assembly. Now, this makes me believe this was designed by someone that was not too experienced on the shop floor of carbon fiber layups and general foam assemblies, but he or she designed that part with the bottom section there, which was removable, because when they inserted this foam part here, it would get caught going in this direction. So the purpose of that part there was you could deflect down this foam assembly here, you could bend it down to fit underneath this undercut here on this side, then deflect it up when it was inserted, and then insert that bottom piece. Now that's probably a bit confusing to some viewers, but someone that's working with mold tools and injection molds, die casting molds will understand what I mean. To be honest with you, I would have done away with that part altogether. There's plenty, I mean, this can conform fine. You could bend it down 20mm to get in the foam insert as one part, but that's just how they did it. So just a general look at that foam part once again before we finish up. So all foam bonded together, machined. Your tape here, these corner inserts are a lot more dense. They're what I would call tooling board. For whatever reason they put these in, just they needed a bit of integrity there, and the main compliance or dampening for in a how would I call it, a side impact was required here and here. So they obviously felt they needed some reinforcement here or strength. You can see how it's joined in there. If I remove that, you can see the part again bonded up from two 60mm or 70mm thick parts, because this is expensive when you get into thick sheets. And again, open cell, the tape is applied to stop the epoxy bleeding in and changing its properties. So that is that part. I think we have it all nearly covered. If there's any questions, feel free to comment. But yeah, a cool part. Cooler than I thought internally, to be honest with you, because as I said, I'm not really into body parts because they tend to be pretty boring or bland. But this one scored fairly high for me internally, and especially the fact that it's number 1 on a test car, which I know now. But yeah, that's that episode. I've put in, before I forget, there was a lot of people saying in the Buy Me a Coffee link they had trouble with their credit card flagging, you know, that it was fraud or something like that, or they couldn't find it. Now it is founded by Stripe or supported by Stripe, so there should be no problem there. But if you do have problems or you can't find the link, I've put a thanks section on the bottom of each video now, just in case, because there is people wondering how I can pay you for these videos. They're great. If you want to donate $5 for brown paper, coffees, future videos, parts, cameras, whatever, hand cleaner, it should be on the bottom of each video now. So look, I'm not asking you to do it, but it's there if you want, and if not, just enjoy the videos and learn from them. But that's that, and a shout out to all the guys stateside. So hopefully that helps with your Formula 3 car, and thanks for bringing up the topic, and I shall see you again shortly with back to basics engine parts, which I prefer, to be honest with you. Talk soon guys, thanks.